35 minutes. Okay, let's do elastic versus inelastic. Do you know the difference between these two?
Flexible, not flexible.
Okay, so elastic collision, elastic. So when we say elastic collision, this is when a collision which both momentum and kinetic energy are conserved. In this one, both momentum and kinetic energy are conserved. In an exam, they'll never ask you to define, but they'll ask you to use calculations to
Conserve the same.
Exactly. Conserved means the same. When we say they are conserved, they are the same. You'll see. So in inelastic, only momentum is conserved. In inelastic. In inelastic collision. Only we'll do some calculations, you'll see how this works. Only momentum is conserved. Okay, so now in an isolated system, we say momentum will always be conserved. And to prove that holistic, if you want to prove or a collision is elastic, we only prove that kinetic energy is conserved. Understand? So now remember, kinetic energy, it's EK, it's equal to half mass times the velocity. You understand that part? Ek is kinetic energy, m is the mass, v is the velocity. You understand? So let's say that maybe you don't understand the what I have on that writing. Let me quickly just try and summarize everything here. So when I say elastic collision, so this is like saying Ek before, it should be equals to Ek after. And then when I say inelastic,
After to before.
they're not equal. Okay?
Mm-hmm.
Meaning that Ek before ilekane is not equals to Ek after. So some energy is lost as sound or heat. So we're just gonna do a quick example. Right. So on this example, maybe I can just give you data. The velocity of a moving trolley of mass. So we have a trolley that has the mass of 1 kg, and then it moves with the v initial 3 meters per second. Okay, and then this is for the trolley. You understand? And then we have a block of, so the block, it has the mass of 0.5 kg. It's dropped vertically on to the trolley. So this block, we're gonna drop it, meaning the initial velocity is what? It's 0. You understand? So we are dropping the block on top of the collision. So all this information, it was before collision. You understand? Right. So after collision, the speed of the trolley and the block, they move together again. So the trolley plus the block, these two, they move with the velocity of 2 meters per second. So this is your V final. You get it? After collision again. So in the original direction, is this collision elastic or inelastic? That's a question. The question will be, is this collision elastic or inelastic? But if you understand how we're going to answer this question, then you'll be able to answer this question. Use calculations to determine whether collision is elastic or inelastic. Now I'm giving you another 5 marks. Ne? But to prove this, to do the proof, ne, you're going to calculate what we call, you're going to calculate the EK before. Again. And remember the formula, EK before, will touch the kinetic energy of the trolley. Ne? Ne? Shall I call it mass 1? You multiply with the velocity of the trolley, which is squared. You add with the velocity of the trolley of the mass B, which is the truck, ne? The block. So this is mass 2 times V of the block squared. Now understand? You do substitution. 1 over 2, the mass of the trolley, we said it's 1. And then the initial velocity before collision, remember, we said it's what? 3, ne? And then this is squared plus, well, EK before, this is before collision. Okay? Then for the second one, the mass is 0.5 and it has the initial velocity of 0. Understand?
So all of them is 0.
Yeah, all of them.
Like this whole side is 0.
Yes, this will make all this to be 0. So you just say 3 squared, that's 9. 9 divided by 2, that's 4.5. So if you punch that on the calculator, you'll find that your EK before, it's equal to what? Your EK before, that's 4.5 joules. Do you understand? So we're definitely going to need this. So this is your EK before the collision. You understand? So now we're going to also calculate the EK after the collision. Ne? And remember, after the collision, this is the mass 1V of 1 squared plus of the second one squared. Boom. After collision, this is what we have. This is the information, but we use the same mass again. So after collision, both of them, they have they move together, so we can definitely add their masses. So I can write this equation as 1 over 2 add the mass 1 with the mass 2, and they move with the same velocity. You get it? Since they are moving together, remember this block will be dropped on top of the trolley. They move together with the same velocity of 2. So we add their masses. The first one has the mass of 1. The second one is 0.5. They move with the velocity of 2. Therefore, you punch this on the calculator, what do you get? Wait. Do you know West Island Farm Village? Which side?
Do you see South Downs?
Oh, South Downs.
You have to pass South Downs and go straight. And go straight for a long time. Stop. You wanna buy something, right? You wanna buy something, right?
No.
Something.
There's a time that is looking me for. I think back to my right? You got?
1.25.
Okay, so now, why is it 1.5? It should be 3. 1.5. You forgot to square the 2. Oh, when I learn, remember the final velocity will be squared again. So we also square this one. And then you get your answer as 3 joules. So tell me, are these two equal?
Yes.
Eh?
It's elastic.
Are they equal?
Oh, it's inelastic.
So EK after. Okay, so we can see that they are not equal. So since they are not equal, what can we conclude? We said if they are not equal, then it's inelastic collision. Therefore, the collision is inelastic collision. You get it? Nice. Okay. So kinetic energy is not conserved and the collision is inelastic. Né? You happy with that? No. Right. I'm not sure where should we start with this, but let's go to energy principles. Né? Okay. So do you still remember what is energy? The definition of energy. Do you still remember? Grade 8, grade 6. Energy is the ability to do work. Energy is the ability to do work. So we have two types of energy. We have potential and gravitation. We have potential and kinetic. Né? So potential, we call it EP. Potential energy, the energy an object will possess due to its position relative to the reference point. I understand? So now EP is equals to mgh. That's the formula that we use. Again, and then kinetic energy. This is the energy an object has a result of its motion, and the formula that we use for EK, it's equals to 1 over 2m v squared. Ne? So in kinetic energy, the amount of energy transferred to an object as it changes the speed. So now that when you understand this, ne, you see this m is the mass, this is just 9.8. Ne? Right? Right. So there's something that you need to understand. Why are we bringing you to potential and EK? You need to understand what we call mechanical energy, which is EM. Mechanical energy, we call it EM. So mechanical energy will be the sum of gravitational potential energy. We take the EP, you add it with EK. Understand? So now this tells you that EM, it will be equals to mgh, and then you add half mass times the velocity. Okay, I can see where you are tired now, right?
I was tired when we started.
Eh?
I'm saying I'm tired when we started, but I'm good. I'm good.
Okay, let's do a quick example. Né? So let's say that I have a ball that has the mass of 500 grams. Né? Is thrown horizontally through the air. The ball travels v initial of 1.8 meters per second, and delta, let's say it travels the height of 2.5 meter. Okay, so from the ground, they want you to determine mechanical energy. Determine the mechanical energy of the ball. Ne? When I just have to know that EM is the sum of these two. So EM it's equals to mg h plus 1 over 2 mv squared. Then you substitute what you are given. The mass of the ball, that's the ball should be in kg. Ne? So we're going to divide this by what? By 1,000. You get 0.5 kg. So always make sure the mass it's in what? The mass should always be in kg. Then this is 0.5 and then this will always be 9.8. Ne? And the height there, you are given the height as what? 2.5 again, plus 1 over 2, and then the mass of the ball we set is 0.5 and the velocity 1.8 squared. So when you punch that on the calculator, you definitely find the what is this? The EM, mechanical energy of the ball.
(13,06).
You got
13,06.
bone. This is not the type of problem you'll get in an exam. Ne? Yeah, in an exam, they will need you to find, they won't ask you for mechanical energy, but instead they might want you to find the velocity or the height of something. So when they ask it like that, this has to do with principle of conservation of mechanical energy. Ne? So you need to know how to state this. Ne? The principle of conservation of energy. Conservation of mechanical energy. Ne? So it says that in the absence of, okay, in the law of conservation of energy applies where there is no, I just want you to know how to state this. Ne? So in the absence of air resistance or any external force, the mechanical energy of the system is constant. Ne? So when they say the mechanical energy of the system is, it's like saying energy cannot be created or destroyed, but it can be transferred. One understand? So the formula goes like this. You see these two formulas, ne? You see these two formulas when you add the two formulas. So this tells you that this will be mechanical energy before. So it's going to be EM before, ne? It's equals to EM after. I understand? Then we're going to say, we know that EM is just potential energy plus kinetic energy. Again, before, and then this will be potential energy plus EK after. I understand? So I'm just going to give you a quick data, then we'll show you how to use this formula. So let's say we have a 2 kg ball. This is ball A. Ne? Okay, let's say this is a before, and then it at, can you see that it's hanging? Meaning the initial velocity of this ball is 0 again, meters per second. So the ball will travel down until it hits the ground. That will be after collision. Understand? So this is at B. So at point B, this is the ball. So the ball will have the V initial of 0. Oh, let's say we don't know the initial that it will hit the ground with, but we know that the height it's 0 because it's on the ground. So this will be 0 meter. You understand? So now we are given the height to be what? The height is equals to 4 meters. So the ball is 4 meter above the ground. At point A. At point A, the height is 4 meter, but at point B, the height is 0. You understand? So we're going to use this information to, they say that a 2 kg ball is dropped from rest at A, and they want you to determine the maximum velocity of the ball at B just before impact. Né? So remember, we're saying that the formula that we use is going to be EP, that's mgh, which we add 1 over 2 mv squared, right? And then this is at A, at point A, before. We equate this to mgh plus ek, which is 1 over 2 mv squared. Né? So now, the mass of the ball, we said the mass is 2 kg. Né? So where there's m, I'm going to put 2. And then this is 9.8. The height at A, it's 4. Then I'm going to put 4. Then I add 1 over 2. And then the mass, which is 2, and the velocity at A, 0. You understand? Then we go to B. Remember, this is at B. The mass is still 2, 9.8. The height at 0 is 0. I mean, the height at B is 0. Yeah, and then we add the mass 2, and then V squared is what you are looking for. Do you see how this works? So this is just 0. We add to 2 times 9.8 times 4.
78.4.
Okay, so this is 78.4, right? And then we equate this to, this is just 0, and then the 2 just cancel, this is just V squared. So I have V squared, which is equal to 78.4. I can just definitely square both sides to find my velocity.
8.85.
Downwards, since it's going down, right? And that's it. Do you understand? I'm sure. Easy, né? Yeah. And then in most cases in an exam, they will give you an object that is moving on an incline, like this. For example, so the object will move an incline and it will come. So let's say it's going up. It starts with the V initial of 3 meters per second, right? And then we know that at this point, the height is 0. Let's call this point A. The height is 0. At point B, it will have V final of 0. You understand? So let's say that we don't know the height of point B. Né? So a 2 kg ball is on the ground. Determine the maximum height the ball will reach at B. They want us to find H. Né? So remember, so when you see this, you can use, in an exam, they'll say, use the energy principle. You just know that, oh, this is EM, the mechanical energy before it's equals to the mechanical energy after. So this is mgh plus 1 over 2 mv squared at A. You understand? You equate this to mgh plus 1 over 2 mv squared at point B. Then you're going to do your substitution. You're going to substitute and see what you get. At A, the mass of the ball is just 2, né? and then 9.8, and what is the height at A? It's 0. Then we add 1 over 2, the mass is 2, the velocity of A is 3, né? And then this will be equated to 2 into 9.8. The height at B is what we are looking for, plus 1 over 2, the mass is 2, the velocity at B, it's 0. Understand? So this is just 0, and then the 2 cancel, we left with 3. It's equals to, oh, remember, this is V squared, né? So it will be 3 squared, and then 3 squared is 9, né? And then this time, that's 19.6, né? H plus 0. So this is just like 9, it's equal to 19.6 H. Divide both sides by 19.6. 19.6. Therefore, that's what H equals to. So what do you get? 9 divided by 19.6.
0.5454646.
0.46. So we just calculated the height at point B. We calculated the height. You understand? At B. Are you happy with that? So this is the first case where the ball will be dropped. The second case is where the object will move on an incline. Number 3. So in number 3, you'll get something like what we call a pendulum. So it goes like this. The object, the ball will start at point A. Yeah. So where the velocity is 5 meters per second, and then it will maybe swing to that point where it will be on the ground, where the final velocity is 8 meters per second. Okay, so now let's say that remember, if it's swinging, it will go up. They won't be on the same level again. So at this point, let's see. So this will be ball, and then this is at B net, and then the velocity is equal to 8 meters per second, and then this will be the height H, which is unknown. You understand? So now at B, we know that the height is 0 again. Let's just calculate the height of the ball. Né? So the pendulum swings from A at 5 meters per second to B on the ground, where its velocity is 8. Determine the height at A. So to find the height, you use the same thing, EM before it equals to EM after. Understand? So we're going to say mgh plus 1 over 2 mv squared at A. Okay, remember it's going to be at A, né? It's equals to mgh plus 1 over 2 mv squared at B. So at A, the mass is still 2, 9.8, and we are looking for H, né? 1 over 2, the mass is 2, and the velocity at A. What is the velocity at A? It's 5. Okay? You understand? Make sure you square that. You good?
They give you a mass of 2.
Yes, the mass is 2. Yeah. The mass of the ball, that's 2 kg. And then now the mass is 2 into 9.8. The height at B is 0. Plus 1 over 2. The mass is 2 and the velocity is 8. And this is squared. So this is 19.6 H plus 5 squared, that's 25, né? Because the 2 cancels. This is just 0, né? And then this cancels 8 squared, that's 64. I want? The 25 will go to the other side. 64, you minus 25. What is that?
39.
39, eh? So 19.68, divide both sides by 19.6, divide by 19.6.
1.99.
Therefore, h is 1.99 meters.
Will you only be solving for age? For all of these?
No, sometimes they can give you like the velocity, they can ask for the mass or what.
I'll just make things a bit of fun.
Yeah, you just substitute and then whatever that they are asking for, you make it the subject of the form.
All right.
Okay. Things about